All right, here we are trying to solve a circuit, and there's no information given about what type of circuit it is. We're going to figure that out for ourselves. But the first thing we can do anytime we're asked to solve a circuit is to make a chart. So charts are always the same beginning. You have V, I, and R along the top, and then we have two resistors here. We have resistor X and Y, and you always have to have a line for the total. So every time we set up a chart, it's going to follow this general path, and I don't know, I'm just going to be fancy. I'll make the grid lines to fill this in. But this is what we want to fill in. Next, we want to figure out what we know from the start. So the first thing they tell us is the total voltage is 30 volts. So under voltage in total, we can write 30 volts. And it tells us the resistor X is 13 ohms. So ohms is a measure of resistance, so I'm going to write that there. And I also have Y's total resistance. And it's saying, what is the voltage drop across resistor X? Voltage drop just means what is the voltage. So my target is this. So this is what I'm going to be putting in for my answer on the voltage across resistor X. So I just need a way. Ideally, you want to solve the whole chart just to confirm your answer. But ultimately, this is what we're going to submit. So first off, what kind of circuit is this? Is this series or parallel? So on first glance, you might say, well, these lines are parallel to each other. You might be tempted to think it's a parallel circuit. But really what you want to look at is how many pathways are there from one end of the battery to the other. So if I start at the positive end of the battery, are there multiple paths the electricity can take? And in this case, there is only one. And so if there's only one path, it is a series circuit. So we're going to follow the rules of series circuits. So remember, all circuits follow the rule V equals I times R. So that's consistent. We'll always use that. But series have a different set of rules. And the rules are the current, because there's only one path, all are going to be the same. The voltages are going to add up. And the resistances are going to add up. So it just takes some practice to get used to these rules. But this is a series circuit. So if you have to go through a 13 and a 20 ohm resistor, the total resistance is going to be 33 ohms. So having more resistors in series increases the resistance. So the way these work is anytime you have 2 out of 3 in a chart in a row, you can find the third using V equals I times R. So we can use this row and say V equals I times R. And so we want to solve for I, which we'll do by dividing each side by 33. So 30 divided by 33 is going to give me the current, which is 0.909. I'm going to round it, but I should be careful rounding. I'll call it 0.91 amps. So there's a total of 0.91 amps going around this circuit from the battery. Now, because this is series and because there's only one path, 0.91 amps leaves the battery, it must also travel the entire circuit. So in series, we know that the current, once you know one current, you know all the currents. And so that's going to help us unlock this. And lastly, we're looking for the voltage of X. So voltage equals I times R. So if we simply multiply I times R, we should get the voltage of X. So 13 times 0.91, I get 11.83 volts. Now, I could just stop there and put that in for my answer if I'm super confident in all my work, but why don't we finish this chart? So what's the voltage drop for Y? So I'm going to do 20 times 0.91, and I get 18.2. And sometimes there's round-off errors, so we're not going to worry about that. But if I've done this all correctly, the voltages should add up, and these two added up gives me pretty close to 30. These two adding up gives me 33. And every single row, if I take my I times my R, I should always get the voltage on the left. This is for all types of circuits. So I can do that and confirm everything and check it out, and it does in fact work. So my answer, what it was asking, the voltage across X is going to be 11.83. So I'm going to use 11.83 volts on resistor X, and I'm going to use 18.2 volts, again, rounded, on resistor Y. And the idea being that you're using more voltage getting through the higher resistance because if V equals I times R, if I is the same for everything, bigger resistance is going to lead to bigger voltage. So that's why they're not the same. But anyway, this is the process that you follow if you're solving a mixed circuit. It's not a mixed circuit, it's a series circuit. But if you're given problems where you're not told if it's series or parallel, you got to figure it out. And I really strongly recommend making this chart, completing the chart if you can, and just checking all these things. Does I times R equal V for each thing? And do all these rules work based on the type of circuit you have? So that's it. I'll have another video with another type of problem you can check out. But until next time, I am Derek Genova. Have a delightful day.